So I've written out the answer up here so that you can check your work. So I replaced the x with 5 tan theta. So when I squared that, we got 25 tan squared theta. There was a 25 in both terms, so we're able to factor it out. Tangent squared theta plus 1 is secant squared. If you remember that, you can go right to that. If not, I'm saying 1 and a trig function squared, I'm thinking maybe there's a Pythagorean identity, and I can always do some side work. So I start with the basic one, sine squared, whoops, this was theta. Sine squared theta plus cosine squared theta equals 1. To get to the one that involves tangents, I divide through by cosine squared. And then this becomes tangent squared theta. This term becomes 1. And this term becomes secant squared theta. Okay. So it should be the case that deriving that takes almost no time. You should have it at your fingertips, but I'm fine if you don't have it just memorized. Okay, I didn't for years. Okay. All right, so then now again, instead of having an addition problem under the radical, it's a multiplication problem. So I can just take the square root of the 25 and then the square root of secant squared. Here's the place where a lot of people are going to lose points if they're not careful. The square root of secant squared is the absolute value of secant. So root 25 becomes 5, root secant squared becomes the absolute value of secant. And then because we're told that we're in quadrant 1, I know that secant is positive, and so I can evaluate that absolute value by just dropping it. Absolute value of something positive is just that thing, and so my final answer is 5 secant theta.